Hey guys, happy Sunday to all of you. So this is Mainak and you're watching Bro. In today's lecture, we will discuss about the loading part. In the previous lecture, if you just watch using the link which has been given in the description, the previous video we had completed the modeling of a G+2 building completely, including the staircase and all the components and using a standard plan. In today's video, we will move towards the loading part and try to complete the building so that you have an idea of how to assign the loads in the Tekla Structural Designer and also perform the analysis and design. And for other interesting features, we'll discuss in the upcoming video. So let's get started for today. And if you haven't subscribed to my channel yet, then you should do that. And if you find all my videos useful, don't forget to hit the like button because it really helps to reach other people. Okay, so this was the thing which we had done previously, and if you're practicing it, you can pause and do each and every step. And if you have any doubts, you can reach out uh, in the comment section, and I'll definitely try to reply to it if I'm capable of doing that. Okay, so firstly, we have to see here about the loads which you're going to provide. Okay, so you can just take out a paper and just briefly, describe about the loads which you're going to provide here. So in the category of the dead loads, we'll have the, sorry, have here the first thing which acts in the dead load is the self weight. Okay, if you want a detailed explanation, you can check out my ETABS videos in which I have explained in detail about how to calculate everything. But here I'll just giving a brief introduction. Self weight, which the software calculates automatically because we have mentioned the grade of steel, we have mentioned the grade of concrete. The software will take the weight of the RCC members automatically. And the next is the wall load. So how to calculate the wall load, there is calculation behind it. I have explained it in the entire video. You can watch that in the dead load part. So it depends basically on the thickness of the wall and the material of the brick, like the file you're using fly ash brick or the your WC blocks or red clay bricks, whatever the masonry you're using, and the height available for the brickwork. It depends. Wall load depends on that. And the next is the floor finish load. So floor finish load is, you can take this floor finish load as 1 kilonewton per meter square. It basically covers everything. It will cover almost everything, including the tiles, RCC panels, whichever thing you want to use as floor finish for your floor. And wall load, you can calculate and take. For now, in the outer walls, I'm going to go with, let's say, we're going to go with 10 kilonewton per meter square for the outer walls, and for the inner walls we're going to go with 5 kilonewton per meter square. In some places the outer walls and inner walls are same in some residential building, like in some most places they use 5-inch walls both for inner and outer these days because of the RCC building. So you can use that also for the same thing. Also, I'm going to use these two different things. And for the parapet wall, I'm going to use here the 3 kilonewton per meter square. So these are the three live loads I'm going to use. Sorry, dead loads, wall loads I'm going to use. How to calculate this? You can check out my video in the detail section. It will depend on what are the things which I have already told. Now coming to the live load, and live load, I'll also write the code behind it because it's very important. Can be asked in any interview. As we're designing with the Indian code, it is as per IS 875 part 1. Okay, 875 part 1 is the code for the dead loads. And if you are going by the live loads, the code is IS 875 part 2. And IS 875 part 2 defines for every individual kind of building the separate loads. So for residential building, we are considering the live load of 2 kilonewton per meter square. So you have to remember that the live load here and the floor finish will act only on the floors which have slabs. So the plinth level, most residential buildings, you don't have slabs. So don't need to assign this two things. But if you're using grade slab, yeah, then definitely you can assign. Okay, so these are the dead loads and the live loads. And next thing which you're going to apply is the seismic load. So seismic load is uh, as per IS 1893, the latest edition. We can apply it. Uh, IS 1893 part 1 is the seismic load, and I'm going to consider zone 5. Zone 5, let the location be in the Northeast India. The entire Northeast India is in zone 5, and I'm going to apply zone 5 here, medium soil. And for the wind load you don't have to take for buildings more than, less than 10 meters. So if the winding is more than 10 meters, then you can take the wind load also. The wind load will be as per IS 1893. I'm not going to take the wind load here since my building is G+2 with less than 10 meters. So its wind load is IS 875 part 3. This is for the wind load. I've also made a building where I applied the wind load. You can check out that, how to apply the wind load. And then is the load combinations. So load combinations is very important because whenever you are sitting in a building, a single load will not act. The combination of loads acts. So for the load combinations as per, we'll apply IS 875 part 5. So the load combinations can be generated automatically. And if you are talking about India, and if you are in Jammu and Kashmir, or you are in some parts of Shimla, there is an additional uh, load for the snow load as well. So you can apply that as well. And if you're designing for a different country, then there will be some different rules according to your country's codes. Okay, so this is the basics. So coming back to the software, we're going to go through it very quickly. So let's apply the wall load first. I'll go to the plinth level by clicking on the structure base, and here I'm going to go to model here, and we can check out what are the options. Here we don't have the loading option here, so we'll go to load, and then we'll select the dead load from here. After selecting dead load, go for full UDL, and first of all, let's apply the inner wall loads here. So I'm applying the inner wall load to each and every primary as well as secondary beams. Will have walls over them. Okay, and this is basically the thing. And I'll not apply inner wall load in here in this particular portion because there's a staircase, and staircase generally has the thicker wall which is available. So here is which is using 10-inch and 5-inch walls, so it will give the load of the outer wall on the staircase. Okay, so let's go with here, let's go with 10. That is the load for the outer wall, and then let's apply this. Firstly, I'm applying it along the staircase section by simply clicking, and then along all the other walls. So by mistake, sometimes it happens that you tend to click on one place twice. Have to check that. And for checking that, you just, if you have, whether you have clicked or not, you can just anyway hover between the 2D and 3D and just check whether you have applied load to a particular position or not. When you have applied the load, you can move to the next level. So moving next level, go to the structure, double click on the structure item, single click will be enough. And after you do that, go to levels here, and simply go to the next level. So the next level is your we'll just go to that. So this is the new level created because of the staircase portion. So it will apply a load on that later. So we'll go to the next level here, and we'll apply the dead load. Please note at the plinth level we didn't apply any particular load due to live load because there is no slab. Okay, so dead load and full UDL once again, and same 5 kilonewton load will apply on all the places which we had applied before. And the 10 kilonewton load will apply on the places where we had applied before and where we'll have the thicker wall. And then let's go and apply the dead load, and this time we'll apply the floor finish load. So for that, we're going to go here, level, and floor finish load of 1 kilonewton per meter square. We'll apply and just click on this, and the load will be applied. You can check here that the load is applied, both the load for the wall and also for the floor finish. Next, you go and click on the impost, and then the level load, and give a load of 2 kilonewton per meter square. So dead load and live load have been assigned here. You can check it. This is the dead load, and this is the imposed load. So what I'm going to do is I'm going to copy this load to this level, not to the terrace level, because the terrace level there will be the parapet wall. Okay. So I'm going to go quickly to model and construction levels, and then I'm going to make this source of your 2 as 1. I'll go this 1 and click on OK. So once this is done, I'll go back to the construction levels and make this as unique, and then click on OK. And then I'll go to the terrace portion, that is structure 3. And in the terrace portion, I'll zoom in using my mouse, and pan you can do using the middle mouse option. Okay. And then we'll just go to load here, and go to the dead load, and then take the full UDL. And here we'll go with the parapet wall load of 3, and we'll apply it in here along the boundary portion. It will still have the staircase, so for the staircase portion, 10 kilonewton load can be applied, because there will be headroom above the staircase. Okay, so now going back to this structure 3D, this is the model, and you can see in the topmost level what we have done. Sorry, in the structure 3 what we have done. So we have applied this load, and since it is a top story, you won't need to assign any floor finish load. So this is it. And if we check in the structure 3D, this is the imposed load, and check the dead load here. So it has been applied. So in the top portion also, you don't need to assign any load, but you can apply imposed load in here definitely. So you can apply it, go to structure 3 and go to imposed, and go click on the level load, make here 2 kilonewton per meter square, and apply it here. So you'll have here in the imposed section, the imposed loads are given, the dead loads have been provided. And now if you want to, put the staircase, load, you can also do that, or otherwise the, self weight portion will be assigned. So what I'm going to do is I'm going to provide, some portion of the weight to this particular portion. So in each of the intermediate levels, you can provide that. So you go to structure 1.1. First, you will go to this space 1.1, and I'm going to provide the dead load as the load for the staircase landing. So roughly, you can just provide the load here, load, dead load, and I'll go with full UDL, and we'll apply a load of, let's say, 10. Can apply the load, it will depend. I'll apply here a 10 kilonewton per meter load here to this portion, and again I'll go here, click on dead, and full UDL, 10 kilonewton per meter to this, and then again lastly select dead, full UDL, 10 kilonewton to here. So it will mark the design of the staircase portion as well. So now once you have done the loading, that is a dead load and live load, you want to validate the model, you can simply go to your load and then click on validate. So the model is validated, and you can see this. If there is any error, it will pop up. Okay, so I'm just adjusting structure window and then clicking on validate once again. So now we can see that the validation is okay. Now we can simply go through with the earthquake load. So for providing the earthquake load, we'll go to load here, seismic load, Seismic wizard. We'll do a zone 5 design, and as per code spectra, uh, zone will select zone 5. Importance factor for residential building is 1. We'll select 1, and ignore seismic below this structure base, that is a plinth level. And then next, we'll use model response spectrum analysis here. No plan irregularities, and here we have options here: RC moment resisting frames without any masonry in fields, RC composite MRF building, steel building without any masonry infills, buildings without any RC structural uh, walls, and all other buildings. So you can see all the data they will take automatically, and I'll go with RC moment resisting frame here, and then next, and then we will select moment frame systems in board, and here you can go with RC building with SMRF, that is special moment resisting frame. So once you go with that, and then click on next, include all the weights, and then click on next, and then finish. So we'll need to create some load combinations. Go to operating, next. All the limit state combinations are selected and the working stresses are not. It may vary depending on the country code. So click on finish, and this is done. And after this is done, you can go to your combination, and time for the combinations, generate the combinations automatically. It will generate the load combinations. Select this load combination also. It's optional. All the limit state combinations are selected. Then click on next, and then finish, and then click on OK. And then after this, this thing is done. Go to design, and you can just click on design all static. So it will take some time, and it will give out the design. So we have the design results here. As you can see, these green members are passing, and the yellow members have some warnings in it, but they are passing. And in the plinth level, in the Tekla, usually there is a warning. You can ignore that always. And if you apply some more load, they become safe. But let's see what is the ratio here. So automatically you work get to the review page, and you can see the ratio here, design ratio, and design ratio seems all right. And I'll make a detailed video on design ratio. But if it's between if it's economical, it will be between the 0.5 and 0.8. So it seems okay, the entire design process. And here, if you want to check the reinforcement of this particular column, you can just right click on this particular column, and go to check member static, and you can check here the 6 bars of 16 mm are in this particular building. And suppose for one particular beam, I've selected, let's say, this beam. So when I'm selecting this beam, there will be 1, 2, 3, 4 spans. So it will go from bottom to top. When you see from the top view, so this will be span number 1, this will be span number 2, this will be span number 3, and this will be span number 4. So we'll right click on that, and go to check member, and then click on check member static. So span number 1 has 2 bars of 20 mm at the top tension, and 2 bars of 16 mm for compression. And span number 2, 212 and 212, span 3 also 212 and 212, and span 4 also 216 and 216. So it's an economical design, and if you want to provide one single reinforcement in all the spans, this is the highest one, that is the load on the span 1, you can provide that uniformly. So that is the beauty of the structural design. If you want uniformity, you can do it yourself. So this design is done, but we'll discuss more about the results. Don't want to make this lecture too much long, so we'll discuss about these results in detail in the next video, and how to generate the outputs of this, and what else we can do in this. See in the next videos. And don't forget to comment, and which part of learning this software are you. You can just leave a comment in the comment section. Thank you. Bye bye. Wherever you are, stay safe and stay happy.